All right, CNT140, we've moved on to our fiber optic book, and we're looking at Chapter 1 on just kind of the basics of fiber optic cabling. Here's our objectives. What is fiber optics? How was it developed? Difference between inside plant, outside plant and premise cabling. Advantages of fiber, standards that we'll encounter dealing with fiber, and a little bit of safety and working with fiber. So let's dig in here. Fiber optics. This is the technology of transmitting light down this thin strand, usually glass, fiber, being able to send data down that strand of glass. This gets used in communications, obviously data communications, but also like voice video communications, lighting, medicine, optical inspections, and so forth. Fiber optics gets used in a lot of areas. For us, our main focus is on the communications aspect. Data communications mainly, but communications aspect. Fiber optics communications the fiber optics in communications works by sending light down this strand of fiber. This began back in the 60s. Some R&D labs, Corning, Bell Labs, ITT, etc., were working with and experimenting and finding a way to move data across a glass fiber. And back in the late 70s, or mid to late 70s, there was actually fiber lines installed. AT&T was one of the first places here in the U.S. out in Chicago. They installed a fiber line. Well, if we do one or two quick, landmarks or timeline events. I'll get it yet. My goodness, one or two timeline events along the development of fiber optic. There's two big hurdles or two big landmarks. The first was back in the 60s. A Chinese physicist, Charles Kao, actually figured out kind of like the threshold. How much light was needed to get through the fiber to actually transmit data. He actually found that almost like the hurdle. If I leap over this, I'll make it. Found that threshold, and actually was awarded the Nobel Prize in Physics in 2009 for this contribution that he unearthed in the 60s. Little side note: Google Doodle in 2021, the Google Doodle on the homepage was celebrating his 88th birthday, which was pretty neat. That was pretty cool. Well, once that threshold was known, once that hurdle was known, other people researching could now say, all right, now if we can make enough data, make enough light get through the fiber to reach that level, we'll be able to transmit actual data through. And it was up in Corning, New York, Corning Glass, Corning, New York, that three scientists, Maurer, Keck, and Schultz, were able to make a glass fiber clear enough to be able to transmit data to meet that threshold. And what they actually figured out was they started making the glass fiber from a gas. If you make it from a gas, it's not able to hold very many impurities at all. So therefore, there's not much in the fiber that's going to cause the light to, hit and scatter and bounce off of. So this actually breakthrough was in August of 1970. They went on to win awards for this contribution as well. And now the door was open to, now we can actually send data across a glass fiber. If you ever do make it up to Corning, New York, there's a Corning Museum of Glass. They have a whole art side of glass in there, blowing glass and pressing glass and glass windows and so forth. But there's also a technical side of glass as well. They have a display in there about their contribution to fiber optics in along the timeline. One of the neat displays in there is they have this giant display of basically a phone cable, if you will, showing all the copper cables that are here, and that can get replaced by that one strand of fiber that's way in here. Just showing how much data can actually be transmitted through that fiber, which is pretty slick. It's pretty neat. So now in the 80s, you're starting to get fiber telecommunications networks connecting major cities across the country. Mid-80s, fibers replacing all the copper, and even in some cases, microwave and satellite links. The 1990s, we start having transoceanic fiber optic cables replacing satellite links between continents. So actually fiber optic cables laying on the ocean floor connecting continent to continent. In around the 90s, mid-90s, your cable TV discovered, hey, we can start using fiber optic to get these television signal out closer to our customers, reducing the amount of copper cabling used. So now, fiber's become a cost-effective way to get connection to your home, fiber to the home, which probably a lot of us do have to the side of our house, and then we have copper cabling inside the house. Here's a reminder about, this was a map of different fiber optic cables connecting continents back in 2015. And then this is the type of fiber optic cable that is actually installed there. There's all kinds of layers of water protection and shielding and even armoring to protect the fibers inside. Just giving you an idea of the cross section there. And then here was traditional cable TV system was pretty much all coax bus network. As they started installing fiber optic, they were using fiber optic to get out to a box in a neighborhood and then running copper or coax out to people's houses. Well, this part here is starting to get replaced as well, or in many places is replaced, where there's fiber going up to the side of somebody's house, and they might be running coax cable inside to get to the actual set-top box or whatever. So that fiber is getting closer and closer out to the user. Internet first transmitted over phone lines, actual copper phone lines. By the 80s, started moving to fiber optic. Cellular communications grew, but now fiber optics is used to connect to the antennas. So from the switching office, from the telephone switching office out to the antennas, might have been cable before, now is fiber optic for all the data out to those antennas, and including in your large facilities, your distributed antenna systems that we talked about before. So here's showing just kind of a city and running the fiber out to these antennas in various aspects of a city. Cities started using fiber optic early, connecting government buildings, schools, city agencies, public safety, fire, ambulance, that sort of thing. And some cities even using fiber optic to connect cameras out at intersections. And even some places, smart cities with connection to traffic lights for, moving data out to the traffic light and also data back from the traffic light to start organizing, better traffic flow, that sort of thing. So a lot of things in a city have migrated over to fiber optic as well. And this is showing the idea here of, smart city, all the different things that are connected in. Many of these are now connected with fiber optic. In our computer lands, our computer networks started using fiber optic in the late 70s for backbone connections, which we'll look at here in a minute. Industrial networks started using fiber optic for noise immunity as well as distance. If you think about large manufacturing plants, they're spread out distance. You also think about all the machinery moving in there, robotic arms, conveyor belt, motors, those sorts of things, moving things around. All that is electrical noise that would affect your copper cabling. If we put fiber optic cabling in, it's unaffected, as well as you have distance to get things out to various parts of your plant. A lot of data centers using storage, or data centers using fiber optic for storage. And in our networks, pretty much all of our backbones are fiber optic connections. And in some cases, even going out to cameras and access points in your building. A lot of fiber optic being used there. So here's just a reminder what we talked about earlier this semester with, here's our traditional copper side of the network over here, and connecting our closets together is typically going to be fiber optic. Fiber optic connecting closets together, connecting your switches together, creating that backbone link. There are some utilities that are also using fiber optic. Some cases for transmitting data and control signaling, but also for sensors. There's sometimes fiber optic installed along things like pipelines and utilities, and that fiber optic is actually sensing if there's an error, a break or something in that utility, whether it be a gas pipeline or whatever. And here's another example of that with along utility lines. That fiber optic is there to sense any kind of maybe disruption that might have caused a leak or something of that nature. Today, fiber optic is either dominant or the logical choice for a lot of communication systems. The costs have come down, making it a lot more affordable for various connections, not just strictly backbone, but other connections in your network. In this class, we're mainly focusing on the communication side of fiber optics. Not really all of the some of these other things we mentioned about medical and those kind of things, but mainly the data side, the communication side. The two types of fiber optics we run into are premise, which is usually a lot of our focus, but we'll also talk a little bit about outside plant as well. Outside plant that would be connecting, our building out to a utility or something like that. Your telephone companies, cable TV, internet connections use a lot of fiber optic. A lot of it is single mode. Most of it's outside the building, so therefore they call it outside plant. So the fiber optic connection coming, from your building over to the ISP that's, maybe buried in the ground or on a telephone pole, that would be an outside plant fiber optic, most likely a single mode connection. And again, these are usually hanging from utility poles, buried underground, pulled through conduit, maybe even be submerged in underwater as well, and designed to go long distances. So outside plant fiber optic has a couple different categories. These are the ones they broke down in here. So anyone that is a utility that's going to hang on, or a fiber optic that's going to hang on the utility poles, they call that aerial fiber. This actually has a steel cable in part of the fiber. That steel cable is getting anchored to the poles. They call that the messenger strength member. And then the fiber optic it's in the same jacket, but almost looks like a figure eight if you look at it from the end. And this lower part is acting kind of like a sling or hammock to carry all the fiber strands. So the steel cable is taking the stress, and this is just kind of holding along, almost like a hammock, holding along your fiber strands. If you have fiber optic cable buried underground, you would have typically armored cabling. So you have the jacket, and then it's kind of like a thick foil shield, and it's there to resist a couple things: water, damage from the weight of material on top of it, but also to resist critters chewing through. Critters tend to chew through things. If you've ever dealt with mice or squirrels or whatever, you know what I'm talking about. Critters will chew through your fiber optic cabling. So this cable is designed to be buried underground. Other fiber optic might actually be pulled through conduits. Many times you'll see this actually being installed along the road. It's a large tube of smaller tubes, and then those conduits you can pull your fiber optics through. So that this could be a form of connection underground as well. You can even have fiber optics installed underwater, under the ocean, if you will, on the ocean floor, if you will. We mentioned this earlier. Here's kind of the cross section of all the layers, and then here's what it kind of looks like from, when you strip all those layers off. And there's varying thicknesses and levels of armor depending on the depth and length and so forth. And again, here's some maps reminding you of all the links that are existing out there. This was 2015. This was a newer one from 2023. This actually is an interactive map. You can look at specific lines and so forth and where they go. It's pretty slick. And then this gives you an idea of the cable, the kind of like the size of the cable, and how in shallow water it does need to resist critters monkeying with the cabling. Outside plant fiber typically has many strands, just a few up to many strands, acting as a connection between two sites or two large internet service provider sites, if you will. Our cable designs are optimized for these, for pulling through conduit, for burying, for aerial, etc. And some of these are going to need special equipment to do. We'll come back in the next podcast and look at some of those.